Hi, good morning, good afternoon, good evening, wherever you are. I'm excited to be joined by Madhu. Madhu is a principal lead engineer at EB R&D. He's a trainer and author of several books, including the second edition of Elasticsearch in Action, which makes him the perfect person to cover fundamentals of Elasticsearch in 3 days. This is the third day, so if you haven't watched the first and second day, we advise you to do that via our YouTube channel. And Madhu, I will be giving the word over to you. Floor is yours.
Lovely. Thank you so much, Adrian, for that introduction. Hi, everyone. Hopefully, you are still with me on the third day of this final session, learning Elasticsearch in 3 days. I know it's a whirlwind of everything, like right from the basics to the little bit of on the search side. We are going to look at which are going to look at today. There's a lot to cover, so certainly I will not be able to. And as you already know, Elasticsearch is a beast. There's so many features that you would think that it's out of the box that are available for us, and it's really impossible for me to cover all of them, but I will certainly cover as many as I can today, this evening. So let's start with the introduction about the text analysis, because I really wanted to mention to you that how Elasticsearch is actually going to do the analysis part, and then once we do the analysis, then we'll start getting into the search side of things as well. So in the search, we are going to look at both term level search as well as full text search. These are the leaf queries, but in addition to that one, we might be jumping into something called compound queries, which is basically an advanced search. And probably if I have some time, I will just let you know how to do a geolocation search or location based search as well. So without further ado, let's start getting onto this one. Let me share. I'm hoping that I'm sharing my screen. Yeah, that's my screen coming up. So I just wanted to quickly mention it to you, one particular thing. So remember, when we do anything whenever it goes into Elasticsearch, the data which is going to go into Elasticsearch, as long as the text field, it certainly goes through something called analysis. So something like, you just have to something like, just take an example of a hello world with like some sort of a the HTML tags here. When this particular document is actually entering into Elasticsearch, is being indexed, what happens is that there are some filters that come into picture. There's some analyzers, or basically this particular text is going to go through a process called text analysis, which is carried out by a module or a software module called analyzer. That analyzer is actually made up of three components, individual components. Some sort of a input filter, so you call it as character filters, and at the end you also have something called token filters, which is basically towards the end of that one. In between there is something called a tokenizer, which basically helps you tokenizing those that text. So in here, what happens is that when you are indexing the hello world, for example, the h2 tags will certainly be removed because you might be using a HTML strip character filter. So that's part of your analyzer. So analyzer is actually going to be employing that character filter to remove those two. So once the tags have been removed, you have hello and world. Obviously both of them are still a small sentence, or two words together. And if you can see this, both of them are, one of them is capitalized h with h, and the other one is completely capitalized word, right? So these two will certainly go through another process or another filter, which is something called, in fact actually it'll be going through something called tokenizer, which does the job of simply removing them, or class sorry bifurcating into two tokens. So in this case you have hello and world. Once the tokens have been produced, the next part is actually going to be lowercasing. That's the filter's job. That is the token filter's job. As you can see here, the hello has been lowercase, so is the world. So the hello world from the top, from the beginning, what you see here is now actually moved into two tokens, which is basically hello and world, right? This is something which analyzer does the job for you. There are out of the box, there are about 7 or 8 analyzers for you, which does the job for us actually, right? Obviously standard analyzer is the one which it helps you. This is the standard default analyzer. If you don't set up any analyzer for your input text, you kind of expect this is going to be coming into picture by default. So whenever I say standard analyzer, what it means is that there are no character filters, and there are two obviously on the right hand side you see you have two token filters. Obviously the stop word filter is kind of disabled by default. You can always enable that. But in addition to that one, there's something called lowercase filter on the filter side. Every analyzer must have at least one tokenizer, so that's the bit you see in between. So you might be having zero or more character filters, zero or more token filters, but an analyzer should or must have a tokenizer to be present. So the standard analyzer, as you can see, consists of no character filters but two token filters, out of which one of them is being disabled, but must have, as a must have, this called standard tokenizer as well. What the standard tokenizer does in this job is basically is going to see any like white spaces or grammatically, it just kind of splits the data or splits the sentence into words, right? That is the job of certainly the job of analyzer. So if I can simply show it to you, how do you test an analyzer? So for example, just take an example of um, there is something called analyze API. For example, let me maximize this one. If you see the analyze API, there's something called you can do a test of your data before you index your data. So for example, sometimes you may be thinking that actually my my queries are not matching the data. What's happening with the data? Maybe it's something to do with your indexing side of data, right? Or maybe something to do with your analysis of your data. So what you can do is that you can certainly check your text, right? So basically in this case, I am using an API called analyze API, and this is my text. So basically any, like, for example, just say something James Bond 007. I am sending this as a text information to the think of it as a API, which is going to be putting the data into the analysis, is going through the analysis process. Ultimately, it is actually going to spit out some tokens. As you can see, there are a few tokens which are coming out. This particular instance, they got a token called James, token called Bond, and token called 007, right? Just the first thing what you need to understand is that that particular J is been capitalized. Although I gave James, for example, even if I give the capital James Bond, for example, that is certainly going to be certainly going to be lowercase. Remember I mentioned it to you on this particular chart that lowercase filter comes into picture. That's exactly what it is doing at this point of time. There is no, because there is no HTML strip. Even if you have HTML strip here, it won't be able to, unfortunately, it won't be able to process that one because there is no HTML strip character filter for you. So that means actually, so all is going to do that is going to just take the H1. Everything else is going to be taken as taken off, but that is going to be available for you. But of course, you can certainly enhance that standard tokenizer to your own way. I mean, you don't need to wait for the to create a new one, but you can always enhance it as per you want. So basically, if I don't use, I mean, this is, as I said, it's a standard analyzer. So you could use that analyze API by specifying the analyzer. In this case, I'm just doing this analyzer as the standard, but I can also use something like a simple analyzer. In the simple analyzer, for example, this is another type of analyzer where wherever it encounters a character, encounters a non-letter, for example, a digit or something like that, is going to truncate that data. For example, in this case, James Bond is certainly is perfectly fine because these are all like English words. That's perfectly fine. However, it had found that there's a non-letter, there's a numeric number. It completely truncated that one. So the simple analyzer is all about truncating the data or splitting the data based on non-letter thing. For example, in this case, even if I have BOND with O being the zero instead of O, you can see that B has been split into those two parts. So that means actually anytime you see a letter, non-letter, for example, that is the one which is the simple analyzer is actually going to come into a picture. So you got handful of analyzers. So for example, we have seen standard and we have simple. You also have white space. You also have keyword. For example, if I take the keyword analyzer, what keyword analyzer is going to do, that is going to just take exactly the same thing what you're going to give in, and it doesn't act anything on that one. It uses something called no op tokenizer. What it means is that the input text is actually going to be written exactly into the inverted index as the output text. So you don't need to, I mean, you don't get anything more than that, right? It's just simple thing that you're going to get it. Perfect. Now, I did mention that there is an inverted index. So what happens is that when you start indexing this indexing data is going to be the data which is going to be indexed is going to be going through this process of text analysis, what exactly I was mentioning it here. But finally, after the tokens have been spit out, they are actually going to be stored into something called a data structure called inverted indices or inverted index. This is something different from the index itself. Okay, so this is an in-memory data structure where you start collecting, similar to your index of a book, where you have number against the number, you have a word, so that you can go and find out where exactly that word is available in your book. You have an inverted index here as well, where whenever you search for James, that James is actually going to say that, okay, this James is available in document 1, document 5, document 10, and then the search is going to, or the coordinator node is going to go and find out where those documents are, which shard it belongs to, which node it belongs to, and ultimately the data is going to return back to you. Okay, so that's the inverted index on that side. But you can certainly, if you are, for example, if you are writing an application for let's say Arabic world, or maybe Hindi, for example. I'm from Hyderabad, so probably normally we use Hindi as the language. So in that case, I can write my own analyzer, or I can write in my own Hindi translation, Arabic, Spanish, whatever the one you want. You can always, I think, language analyzers are pretty good in Elasticsearch. There are almost I think 30 or 40 language analyzers. I might be wrong there, but I know that there are lots of language analyzers available out of the box, so that you don't need to worry too much about that. But of course, if you want to enhance this one with with your own analyzers, certainly you can do that one. All you got to do is that, for example, pardon me, if I need to create my own excuse me, I'm just going to create my index, for example. Just this time, I'm just going to say that I'm going to create an index with stop words. That means I don't want the stop words in English is basically the ones which are like the a and the, those kind of words, right? I mean, you normally don't need them. You don't need them for the for your analysis purposes. When you're going to Google, you don't search, can you find me a cabin, something, for example, right? You don't say find me cabin. You just kind of use the words without having these stop words in between. So you certainly can avoid them, or if you want to add them, you can certainly add them as well. In this case, I'm going to create an analyzer on the index itself by using the settings API. So I'm just going to say my analyzer is being, probably give it a name, say is, let's say, stop words, for example. My stop words, I mean, this is your name of your own analyzer. Okay, this is what you're going to give it to them, and you simply open the object. And what type you're going to do, you're going to say, my type of this is certainly a stop words or standard, for example. And you say to standard, to this analyzer, give the stop words being the English stuff stop words, or German stuff stop words. It's up to you, whatever you want. You just simply say English is my, for example, I'm just going to give this one. So what it means is that I am creating an index with an analyzer called my stop words, and that analyzer is a standard analyzer. It's actually going to be invoking, or is going to be using English stop words. So that means you are actually expected to drop, or in fact the analyzer is going to drop all those words which are like a and the, all those articles, actually they're going to be removed. I mean, obviously you can change this one to, if you're looking for a German, for example, you can simply use the German stop words as well. But ultimately, this is a way you can always create your own index with your own analyzer. There's a lot more things that you can do with this analyzer. Obviously, time is my problem at this point of time, so I may have to jump straight away into a little bit more things on the analyzers. The reason I wanted to mention it to you about the analyzers is that the takeaway point is that when you're indexing the data goes through this analysis process. However, the data, which is the textual information, the data types being text, they are the ones who are going to be going through this particular process, whereas the numbers and etc., they will not be going through the analysis process. They have a different indexes that will be going in there. This brings to the next set of things, which is basically the search side. What I wanted to introduce you to search is that you have in search, you have two kinds of data, right? I mean, basically, obviously, Elasticsearch stores both unstructured as well as the structured data as well. So unstructured is basically where you are actually going to be, um, structured is basically where your normal data, like for example, I have set of flights, I have birthdays, I have classes, I have cities, all those things is very, very much structured, right? Whereas unstructured is like human readable language, like English, where you have blog posts, you have video files, you have all the information which might not fit into a particular form or shape, right? So you're going to start searching for that particular data is actually going to be a little bit of a difficult thing unless you have some unstructured features of search available on that particular product or in that particular product. So what Elasticsearch does is that Elasticsearch is going to give you a little bit of a help in creating something called full text queries by for the unstructured data, whereas term level queries on the structured data. So basically, ultimately, what you do is that most of the time you are actually going to work with full text and the term level queries. I mean, obviously, these are leaf queries, that is, they're independent individual queries. We are going to see a compound based query in a second, towards probably a second part of the session. But for now, just imagine that you are actually going to use this part of full text for the unstructured data and the term level for the structured data queries. Now, just a very, very high level, basics of search that I need to explain to you. There are normally, you just have two types of two ways you can invoke the search. One way is obviously is the using something called URI requests. I'm going to show that example in a second. And the other one I think I showed you yesterday, which is basically the query DSL method. So both of them are pretty easy, pretty good to follow. However, I would say probably URL requests might be easy to start getting with, but unfortunately, as your terms, so as your search criteria grows into a little bit bigger, you are going to have complicated, complex, erroneous sometimes query requests that might form out, and you might have a little bit of a problem there. So normally, query DSL expresses really, really very well whatever you are expected to work on that one. For me, in this particular instance, I have something called movies data already established, but you can go to my GitHub, get the movies data out of the box, and you shouldn't have to worry at all. You just index the movie mapping as well as movie data, and you can get through that straight away. So because I got movies, let me first show you my movies search. Whenever I do this search, I should be able to get some data. So you can see that I have 26 movies in my database, in my Elasticsearch, and you can see that there's a hits here which tells me individual movies. So if I minimize this one, you can see every movie is kind of given to you. One quick thing here is that normally you will have about 10 data points or 10 results that normally Elasticsearch returns to you. The reason is that by default, 10 is the maximum number that any result set is actually going to bring it to you. But you can certainly change that one by writing a query if you want. I mean, using the search, for example, in this case, I'm just using a match all query, which again gets you all the 26. But of course, you only get the results being the uh, uh, 10 results. But you can certainly change the size to 26 or 20 or 100 or up to 10,000. You can change the size. So in this case, I got much many. As you can see, I got 20 results back to me. So this is something which you can certainly use it. But of course, you can always say there's another field called from. Using the from and size, you can do a pagination as well. I'm not going to go through the details here. Full of examples. The examples are available on the GitHub. You can pick it up straight away. So size aside, this is equivalent to whenever you call the match query like this with match all it's saying is that get me every damn data in this document, in this index, right? That's exactly what you're going to get which is also equivalent to this particular one. So this or the other one, match all, is actually the same thing. You don't need to there's no change in that instance. The only thing what you can do is that you can change the boost here, in the sense like that I will introduce you to the score in a second. That boost is basically to say that instead of getting the score of each document being 1, give me the document being boosted to 3. So that means each of the score of the document can be changed from 1 to 3. So now I have just barely introduced you to something called scoring or score. That score is nothing but a relevancy score. Relevancy score is something which you will certainly come into at some point of time you will really be introduced to that. So let me show you very very quickly what exactly relevancy is at. When you make a query, for example, if you are an online electric store, and if you call, if you say that, get me all the TVs, for example, not every time you're going to get the TVs 100% on your screen. For example, remember when you go to Google, when you search, maybe there are 3 or 4 pages. You don't normally go to the fourth or fifth page, but there are some queries or some pages or some links in the third and fourth or second pages which they are not relevant to what you're asking for. Just like that one, when you go to this electronic store, online store, maybe you're not getting the I mean, you might, the top results might be, 6 TVs here. I'm exactly getting them, but in addition to 6 TVs, I'm also getting two other products which are like, camcorders and projectors as well, right? So this means, excuse me, there are true positives, that is 6 of them, which are been put forward to me, but there are other 4 which are not necessarily the right ones that needs to be put, put forward in the result set. But those are called false positives, right? So you take the ratio of this, how many TVs been returned and how many TVs you have in the stash, then that becomes a precision. This is a very important concept, because the more precise you want, that means actually you may be getting 100% results back, exactly the what you want, but at the same time you might not be able to give more results back to the user. So that means there is another concept called recall. Again, I won't be able to go too much in detail, but here if you look at it, right, on the circle you have, so on this particular one I have returned these many results, but in addition there are 3 more TVs which are supposed to be part of the result set, which are not included here. That means they've been left out. They've been, for by my search, unfortunately search kind of a failed in that way, that it managed to go and left them out. So that means there are false negatives. However, these 3 which are supposed to be not sent to the results, they are sent to the results, so they become a true negative. So you got how many retrieved TVs over how many eligible TVs, that gives you the recall. So there's always a kind of a tug of war between these two, precision and recall. Do you want the higher precision? That means your data is actually going to be exactly what you're looking for, or that means actually your return results will be less, or the recall is going to be the other way around. You kind of send more data to the user. Some of them might be bad results, some of them might not be relevant results, but you still want to send them to them. So it's up to you how you want it. But let's get back to the relevancy score. So every document, whenever you do a search on this full text documents, full text fields, what you do is that you are actually going to get the data back to you with some sort of a score attached to that, and that score is nothing but called a relevancy score. So when you go to Google, when you do a search on the Google, like for example, when you search something on the iPhone or something on your Android phone, for a particular keywords, you are going to get set of results, and then Google is going to show you one by one results, right? The top of the result is the most relevant result, right? That is close to you what you're asking for. Obviously bottom of that result is not necessarily what you're asking for, but it could be, kind of a varied result what you're not certainly looking for, right? So that means how is this particular data is going to be sorted, is sorted something called by relevancy score. So the top one is the one which is much more relevant to what you're looking for, hence it has got the highest relevancy score, whereas the bottom one probably not necessarily that much of a relevancy, that it's not equal to you, it's not something that you are looking for. So the score of that document might be not necessarily the high one, right? So that's the default sorting of the results that Elasticsearch does that for you automatically. Of course, that only works on the text fields. That's something which we're going to see that in a second. Now, remember I mentioned to you that there are 2 types of search that you could invoke. The good thing is that both of them are actually going to be, that is the URL search and the query DSL search, by the way. Both of them are actually going to use the same endpoint, which is something called underscore search, which we have been seeing in the last 2 days. So let me show you one quick one. So when you start searching for movies using a URI, so I'm just going to use something called search. This is my search endpoint. I'm going to make a query like using Q. So basically all I'm doing is that, your query at the URL itself, right? I'm not constructing any object like a DSL object here. Instead, I'm going to say search for title called Godfather. I mean, that's exactly what I'm going to do. So, just get me, you are asking me, Mr. Konda, go and get me all the data which where the title of the documents should be matching with Godfather, right? So I got three documents. The equation tells you that tells you that there are only exactly three of those documents, which is perfectly fine. The maximum score, this is your relevancy score I was talking to you a few seconds back, is the top of the document. Whatever the document you have, the equivalent to your the same document. So in this case, I have 2.16 as the maximum score for that particular document. So this particular document, the one which you see here, most likely the Godfather, that's the highly relevant document. I mean, that's something that's the reason why you got 2.16. And probably there's a second movie as well. There's a Godfather one. There's a little bit, maybe a little bit less, or maybe something same, I think. Probably, yeah, it's the same thing, same, exactly same score. But there's a third document, right, which is the title is Godfather Part 2. That seems to be, though it's Godfather is matching up, the score seems to be a little bit lower on the scale. I mean, there's a reason for that one. Of course, you can certainly get the reason. I'm going to show you how to get that in and explain APIs when we are doing the query DSL. But you can extend this one to have something like, for example, in addition to this one, you want some actors to be, let's say, I don't know, Al Pacino, right? Al Pacino's actor. So basically, that might give you a little bit more. So, for example, in this case, I got two documents with just remember the third document which we had, that was gone because this is not going to be this particular one is certainly going to look for the Godfather as well as in the actors Al Pacino. So that means there's an actors here, so it's going to look for the actors document, so actors input, and this one, so that it's going to go and get the data for you specifically. Of course, if you leave it here, that's basically what it means, is that it's actually using the operator as the or, and that it might get a little bit more extra data. That's exactly what you got it here. Did you see that there's a score which has been highly gone up a little bit high, because it's now calculated the score using the BM25, which is the best match 25, which behind the scenes uses the term frequency and the inverse document frequency, obviously field length norm and those things to calculate a particular score. Again, as I said to you, hold on for 2 more minutes, then I will show you how to see that score as well, how that score is going to be calculated as well. So that's the pretty much on the, I mean, as you can imagine, you can start looking at sort, you can start looking at you can if you want source includes, etc., you can just do that one, and so on and so forth. However, this particular query is certainly going to help you out. The problem is that it's going to become erroneous or error prone the minute you start implementing a little bit more on the query side. The more conditions you take in the query, then this might become a little bit difficult for you to manage and obviously to write as well. So that leads to the second one, which is basically the get the DSL, the query DSL, right? So if you look at the query DSL, it's pretty straightforward. I mean, you don't need to worry too much about. I think we already seen this one. It uses exactly the same endpoint, which is the search endpoint. Inside the search endpoint, what you have here is that. Let me check my. I'm just checking the notes to see actually if everything is fine. Okay, that's good. It looks like everything is fine. I didn't lose any connection. So sorry, when I go back to my query DSL, what I'm going to do is that I'm going to open a request object here. Inside my request object, I'm going to write a query, right? I can start writing a query, like for example a match query. So what it means, a match query is one of the common query that we always use, so probably it's very straightforward to understand as well. Match query is going to say that, given a field X and Y and Z, find out if this particular data exists in that field. In this case, just think of it as, let's say, Godfather in the title field, right? Field is my title, right? That's what I'm going to do it. And I want to check for Godfather, for example, right? If there's any movies called Godfather, all I'm trying to do is that match all the documents in my movie stash where title seems to be equal to Godfather. That's exactly what I'm trying to do here. I got three documents, which is pretty straightforward. You don't need to worry at all. You got them very, very easily. right? So this is like we just going to go into a little bit details around the query, sorry, around the full text queries and term level queries, but let me introduce you to some basics here. So, for example, as I mentioned it to you, this is a score based, returns, right? So basically, or they're all sorted by score, but you don't need to sort, you don't need to wait for that sort. You can also create your own sort as well. So that means if you really want to do some sorting of your own nature, of your own field, you can say that. For example, in this case, I think I have some rating for rating. Yeah, there is some rating. So basically, instead of the order by the score of the document, I want to order by rating of the document. So in this case, as you can see, I completely changed, right? I mean, I may have got it by a different order now, actually, right? Rather than having on the other one, basically, there's no order in here at all. So I changed completely, the dramatically I changed it. And obviously, as you can see, because I changed the score, a score rating, or the sorted by score, by a different attribute, that means there's no point of calculating the score by Elasticsearch. So it completely ignored your score, right? And ignore calculating the score, right? This is something which you have to keep in mind. Sorting is very, very important, especially if you are looking at sorting anything other than your relevancy score. um, you may have one more thing I wanted to introduce here, and then we jump on to the term level queries. There is something. So, for example, when you are searching this one, you really don't know if it's, for example, especially if it's a synopsis. Inside the synopsis, if you're looking for some, let's say, God, you really, if the synopsis is like a A4 page, kind of a 3 or 4 paragraphs, and you really want to know where exactly those words were matching, then you can do something called highlight. Highlight is the one which is going to help you to say, oh, this is a place where synopsis been, I mean, this particular match occurred, right? So for example, if I do this one, obviously I don't have anything looks like a Godfather. Yeah, that's the one, which I'm going to get that. Hmm. So what is the reason synopsis? Okay, this looks like there is nothing in the synopsis that have that particular match, so that's the reason. But look at this one. So I kind of got a couple of documents for this one, but at the end of the document, this one should be now title rather than synopsis. If I change that one, so if you see towards the end of that one, there's a highlight object which tells you that in the title field, I got the match called Godfather, and that's where it's been emphasized. So this is basically when you send this document to your UI client should be able to say, okay, this is emphasis. That means it can be highlighted as bold or colorful. If you can change it, highlights, you can change it to your precursors and post cursors to change whatever, right? You don't need to have a em being the emphasis, but you can always change it according to your own UI client's definition, right? That's something which you can always do that one. Now that leads to the final part, sorry, the next part, which is going to be the term level queries, right? I mean, I certainly have to go through with you the queries which are term level. As I said to you in the beginning, term level queries are against the structured data. That means when you do a call to invoke a term level query, the expectation is that either you have some data or you don't have data. That means your results are actually going to be like 10 results if there are 10 cancelled flights, or none, because there's no cancelled flight for that particular day, for example, right? So there are binary options. You are yes or no, similar to what you get the data from your database. So if I mean, we will see a little bit different to when you go into the into the into the world of full text queries. But one quick thing you got to understand is that always remember, because there is an analysis that happens for the indexing data, the data is certainly going to be input into the index, and then when you're writing the queries, term level queries, that will not go through the indexing, so that will not go through the analysis part. So that means whatever you give in the term level query, that's actually going to be searched against the inverted index, and if there's a match, you're going to get the data. Otherwise, you will not be able to get the data. But that's something you will certainly have a quick look in a minute. So if I do a movies, like for example search, I'm just going to use a very common query. I'm just going to write a query, and this query is a term query, right? So let's say I want to search the data with all the certificate or movies, for example. Excuse me. I got 14 of them, right? Obviously the score is pretty low, but doesn't matter. You can see that there's all of them are pretty much R rated, right? Keep in mind, I mean, you can change this one instead of certificate, you can always change it to title, etc., etc. But normally what I would strongly suggest is that text fields, you can, I mean, like for example, let me change this one to small r. That doesn't match. Why would you say think? Because the reason is that the term level queries will never go through analysis. What it means is that your capital R is, your small r is actually going to be can never be analyzed. It's not going to be matching up with the data what you have in there, right? Obviously you got to worry about, and then you can just use something called certificate.original, and then you can go through using that one. um, you can also have something like, this is a very very simple term level queries. By the way, this is a long one, but you can also use title. In this case I can simply say the Godfather. That will give you the data, but remember I'm running the term level query on a text field. Ideally I would strongly suggest that you should use it on the non-text, I mean non-text fields. You can certainly boost your queries as well. Absolutely up to you. But I think one of the things I always look for is the range queries on the term level query side, including the ones which you seen yesterday, that is the IDs query as well. But the term level query, for example, if in the term level query you can say something called range query. Let's say I have a rating, maybe I don't know what is the rating we have at the moment. Let's say I want greater than 4 and less than probably 10. Maybe that's what I wanted to find out, all the movies between that rating. So I got 24 items or 24 movies with that particular rating, right? I mean, obviously I can change it to greater than 9.5 and less than 10. That means actually I'm going to get none actually. So I don't think that we have any movies of that order, but you can change it to the bits. Then you can certainly tweak them to get the data what you want, right? So there are multiple, I mean, like, you can certainly have a lot number of queries, including wild queries, including prefix queries on the term level. One last thing I wanted to show you is the fuzzy query. Okay, so fuzzy query is a query where you make some mistakes in spellings, right? So basically whenever you make a mistake, that there's a problem with that. I mean, you have to honor that mistake. I mean, of course it's not that you should honor, but you can always think it as customers always make mistakes, so you may want to honor that mistake, and then go and get the data as per expectation, right? So let's say I want to in the genre field, for example, I'm searching for a value. For example, I'm searching for drama, but instead of drama I have managed, or the user did not give the D field or D input, right? So that means it's a spelling mistake, right? So how do I manage to get this one done? I mean, like, if I search, certainly if I input that in, if I just do the job of invoking that one, I wouldn't get the data back to me, right? So what I would do is that I'll wrap that up in a fuzzy query where I have given something called fuzziness. In there, what I'm saying is that you kind of ignore one addition of a new letter or a deletion of a new letter. It could be anywhere, doesn't matter, it's first or second or third, doesn't matter, and check that one. So that means actually Elasticsearch is clever enough to go around, search for all the words which has one addition or deletion or modification the letter. It uses the 11 times edit distance to go and get the data. For example, in this case it went and searched for all the drama ones, right? I mean, you can always change it to, for example, if you take two of them, you may have to, unfortunately that will not match because you are looking for two words change. In that case you may want to change the fuzziness to 2, right? That's the expectation on the term level queries. I mean, sorry, on the fuzzy query. So keep in mind, you may want to change it to fuzziness to, it's up to you. But normally there is a function called, if you don't, if you leave it like that, you can always use something called auto. Auto is basically based on your length of the word. It can be managed by Elasticsearch itself. For example, if your length of the word is 1 to 2, or sorry, 0 to 2 letters, then probably your fuzziness is not going to be there anymore. But if your length of the word is probably from 3 to 5, usually it considers as one letter, so you don't need to give, for example, in this case usually it kind of go automatically uses a fuzziness being 1. But if it is more than, if because it's between 3 and 5 letters, right? But if it's the length of the word is much more a little bit higher than 5 or so, then you are expect, or you are actually expected to have a fuzziness set by Elasticsearch as 2 by being the default. Okay, but that's that's always in the documentation. You should not worry about that much. Now, one quick thing you got to keep in mind is that um, the term level queries are certain. You can certainly run them on the text fields as well, but expectation is that they are pretty much on the structured fields that you're going to get the data yes or no kind of a thing. I do have to jump onto something called full text that brings to the conclusion on the term level queries. The second part to that one is the full text queries. That's where the meat is all about, right? Full text queries are the ones which are pretty much like you use them. This is unstructured data. You are actually going to look into the relevancy of your data when you're looking at the full text query. So basically, whenever you're calling Elasticsearch or search engine to go and get the data, it's actually going to get the data the way you are, not just you are asking, but it will look for root words, it look for synonyms, it looks for grammatical other things, and it could be fuzzy queries as well. So it's going to do a lot number of things, and then it's going to find out, oh, if this is something what you're meaning it, right? That's something which is going to give it to you for your benefit. So basically, all full text queries or the queries run on the full text are actually the full text queries, which is basically your structured data. I think we have already seen match query, which is basically one of the most common one. So I really don't need to go back to that anyway. So we can just we can move forward. Um, I think we also mentioned it. I also mentioned about the operators. I think, but I don't. I think based on the time, probably I'll just move forward a little bit more on that. So you can also, you kind of go through fuzzy queries in match in the full text as well, because we just searched that one. So I think I may have to switch my gears to books now, because I think there's also another one called books index, which I created earlier. So if I use a query, for example, remember the match query, we already seen the match query, so I don't need to keep on banging on that one again. But this time I'm just going to show you something called title. In the title, I'm not going to give a simple one. I'm just going to expand that one. I have something called query. Here I'm just going to say, instead of Java, I mean, obviously if I have a Java, you would go get the data of 8 books, right? Let's say I managed to input incorrectly something K, right? Because that's something which I really managed to give an example, give a spelling mistake being there, right? So here as well, you can simply say fuzziness, set it to 1. Remember, the difference is that this is a match query with a fuzziness. The previous one is the fuzzy query itself. That's a term level query, and this is a fuzziness in the match query, which is a basically a parameter of a match query, which means is a match is a full text query, right? So that's, now you can go, you can see that you are setting the fuzziness, and based on that one, you are actually going to get the data straight away from that. I mean, that particular spelling mistake has been ignored by Elasticsearch, which is really really great in that matter. Now, in addition to must and match queries and etc., let's say I wanted to search for this phrase, right? This is the phrase I wanted to search. What I would do is that I would certainly create a new query called match phrase query. Excuse me. I wanted to search on synopsis field, because that's where the synopsis is. Inside my synopsis, I am asking Elasticsearch to go and search for exactly this phrase. That means any book which has got this particular phrase embedded in the synopsis field is going to go and find out. Looks like there's only one book which has got exactly the same. I mean, you can always use the highlight to get that highlighted as well, but that's exactly what it is doing at the moment, so that's perfectly fine. However, sometimes you don't need to get the same thing. Let's say I dropped the one word there. I know, like, for is been taken off because for whatever the reason I ignored that word. Now that will not certainly that will not match, because it said you have from your phrase what you're giving me, one word was missing. So in that case, what you can do is that you still have some, you can do a little bit of a jiggery pokery here, that you can write your query here. Inside your query, you can simply say the same thing, but this time I'm going to have something called a slop, where slop means how many words do you want me to ignore. That's what is asking me. The Elasticsearch is asking me, Mr. Konda, do you want me to ignore one word from this phrase or two words from this phrase, so that I can go and search on my database, right? So in this case, I said, I ignored one search, sorry, one slop being one, because I have removed one, probably one word I may have removed. Go and find out the phrase with this particular document, sorry, with this particular phrase. But certainly one word being missing, so it still went, and in spite of me being not having that one, it still went ahead and do that one. But the same thing, can it happen if I take two words, or that, because now you got two words, it certainly does not match, right? In that case, I can certainly increase my slop to say, can you just go on increasing the slop to 2, and then still go and get me the data, right? So that's pretty, like that's a query phrase that will do the job. I mean, it's sorry, match phrase that does the job for you with slop, right? I mean, that's a pretty straightforward thing. Now, sometimes you may want to have, let's say, if I'm running like this, you may want to have some prefix, right? In this case, like program, Java programming, or Java programmer, or a Java program. You never know. There could be some different words, right? You may want to search on that one. In that case, what you can do is that you can use something called match prefix. Match prefix works exactly the same thing, except that you don't need to give the full word of programming or programmer or program. It kind of takes it as a star there, and then it matches to, like for example, in this case, it matched to programming because that's what it is, and so on and so forth. I mean, there could be a programming here as well. If you have a programmer, it could certainly look at the programmer as well. So the prefix queries are all about having a match of the phrase itself, plus the last word of the phrase is going to be prefixed as well. So it's going to look for the prefixes on the last word. Okay, so again, there's multiple queries here as well. You can, there's something called query string, etc. But ultimately, there's actually, I just want to show you one more little thing here, and then we'll jump on to another concept. There's something called multi-match. So far we've been working, or we've been looking at the data across one particular field, right? Because you're looking for Java in one field, or Joshua in one field. But can I search for a piece of information against multiple fields? So for example, I want to search Java, but this time I don't want to search across just the title, but I also want to search across tags, across probably tags, for example, across maybe I want to search in synopsis as well. So is there any book which has got Java, mentioned it in multiple fields, so across multiple fields? So in this case, if I do a search, I got 12 books, right? Fortunately, I got 12 books, but you can see that in the tags, you see that there's a Java that's been mentioned. That's why you got it there. And you certainly have double time or twice here, so you got it there as well, and just in the title you got it there as well. So basically there are some books which has got all those things kind of matched very well, right? So this helps you to query against different fields, right? Obviously there's a little bit more to this one, in the sense like how exactly is going to derive the score. Is it because if it finds in two of these ones, does it going to become a high score, or does it have to have three fields that it becomes high score, right? Obviously there are few algorithms behind it. Normally by default is going to use the best fields, but you can certainly reach out to the documentation, or if I can put a shameless plug, I have discussed this at length in my upcoming book on the Elasticsearch in Action, second edition as well. So you can certainly go and check that if whenever you have a little bit of a time, right? So with that, now you have looked at all these queries. What you looked at, whether it's term level queries or full text queries, they're all individual leaf queries. So basically, you normally have to worry about building your search criteria with multitude of options. So for example, you want to find out books written by Mr. Joshua, also probably the edition being third edition, maybe with tags being computer science, maybe with an additional what do you call synopsis having x and y and phrase. All these things will become your when you go to an online store, you have these options, right? You don't want to buy a laptop just simply just putting a number or something like that. I mean, you can always do that, but you want to say RAM, you want to say make, you want to say model, you want all those things. So these are all becomes a much more complicated and compound complex queries, right? So Elasticsearch helps you in providing those compound queries in the form of something called creating those advanced queries in the form of compound queries. Okay, so compound queries is nothing but aggregation of your or agglomeration of your leaf queries. So you have a certain leaf queries that you start building them up into different clauses, and then that becomes a compound query. Let me show you what I mean here. So let's suppose I have if I go back to my books again, let's say I have books here. I'm doing a search here. In here I'm writing a query, but this time instead of writing a match query, term level queries, etc., I'm just going to write another query called bool query. Excuse me. In this bool query, it's a Boolean query. That means actually it's got some clauses in there. What kind of a clause it has got? It's got must clause. So that means you can simply say anything which matches these must clause can certainly be part of the result set. Okay, that one. You can also say, can I also say, in addition to that one, can you put me some more clauses to say that though these are the clauses that is going to be searched or matching against the search criteria, I really don't want something in this one. So basically, like for example, if you're looking for all the fridge items which are energy rated with A++, but you say that though you're going to get A++ items, they must not be of color white, for example, right? That means in that case you're going to put that into must not, right? So, and like in addition to that one, you can say, okay, however, if the in addition to this, to anything after this one, all the results, will there be a match in any of this criteria which I'm going to put in the should clause? If there is a certainly if there is a match, then bump up the score, because should clause is actually going to say, it's kind of an or clause which tells you to bump up the score. But if it doesn't match, there is no change at all, and the query is not going to be failing. And finally, filter. So you can also use the filter clause. What filter clause is going to do is exactly like must, but the only difference is that this is going to be executed in a filter context. That means your scores are not going to be created, or scores are not going to be run through. That means you are not exactly to worry about that particular scores. Okay, so in this instance, I can just simply say let me quickly go through one by one. I mean, not all of them, but I just might go through in my must queries. So for example, I want to run a match query. So what do you want to match? You want to match against a field called Java, for example. What else you want to do? You want to say, maybe in addition to must match, I may want to say range query as well. That means I want to say edition being probably greater than second edition. You can just see that. So now you are actually trying to build a little bit more complicated and complex queries. So for example, obviously I have a problem here, something I misled or misdone that one. But the idea here is that you are actually now building up a range query and the match query together by for the must query. So basically you are building up your queries as you go along, right? So which is really cool, because at the end of the day, you are trying to complicate your query, but at the same time you're trying to bring all these leaf queries and start building them up to do the job of creating for you, right? I think that's your must. Basically, must is obviously going to be anything which doesn't match in the must is certainly going to say, oh, I'm just certainly going to take off that. I'm just going to filter them out, because I don't want anything which does not have like for example, I don't have anything which sorry, let me take actually and see if I can get an example up and running. Hopefully that will do. Yeah, okay. So in this case, I'm searching for all the Java based books, which I got everything in here. So that's the title being searched against that one. That's perfectly fine. So you got your match query done. You can always query, you can always have a little bit more if you want. You can just simply add a range query, or you can have a term query there. But you can also have something called must not as well, as I mentioned it to you. So you can simply say, in this case, I can say must not. I'm just going to say okay, Mr. Konda has brought this all these books with the title being Java, but maybe I don't want Amazon rating, for example, to be less than 4.5, for example, right? In that case, what I'm going to do is that I'm going to put that into must not. In here, I'll say my range query should be on a Amazon rating, right? Here, probably I don't want, maybe it's less than, actually, less than, yeah. I don't want anything less than or equal to 4.5 or 6, something like that, right? So that means get me all the Java books, that's perfectly fine. However, ignore any books which is less than with rating less than 4.6. That means your books now narrowed down to only one of them, because that's the only one which has got over 4.6. I mean, if you want to change that one, you can change it. I think you may get one more extra book if I'm not mistaken. Yeah, you can see that actually. So this is your must and must not. So that means actually you're trying to you know include a little bit more. I mean, you're going to create a little bit more complicated query by doing this one, but of course you can always use the should clause, which will certainly increase, like, if I minimize this one, if I minimize this one, if I minimize this one, I can certainly have another query called should clause here. In the should clause, I can say you can write your own match query here. Let's say probably author, and if the author is Joshua, then in that case, probably, for example, in this case I got 1.4. If I run this one, if Joshua is the author, which is certainly matching up this one, that score should bump up. So you can see that the bumped up score for the same query, but matching up with Joshua in my should clause, certainly gone up the query. That means actually the sorry, it's gone up the score. That means that's the beauty of should clause, to say match this particular word, and if it matches, certainly bump up the score. And obviously the filter one is the one which tells you, just to ignore that one. So for example, I can simply say filter anything which has got, let's say, term on edition, for example. In my edition, I want to have, if it's a first edition, ignore them, right? So in this case, looks like everything is first edition, so I don't have any queries, anything which has been spit out here, right? So that's the beauty of compound queries. You can start building up your queries as you go along, which helps you a lot more. You start building up. You can, it's not, it's a world is oyster, right? Because you can start creating as many queries inside your must clause, instead your must not clause, and you can start building up. I mean, this is not just one compound query. You also have other compound queries. So for example, you can have something like a percolator compound query, or sorry, percolator advanced query, which helps you to alert you when there is a, like, for example, when you do an indexing of your document, and when the user searches for the document earlier, and he or she might not have the document in your stash, but maybe you have inventory, you have your inventory has upped up overnight, and you want to send a notification to your user, then you may want to run this percolator query on that, or behind the scenes it will do the job for you. You may have boosting queries as well. You can just simply create a boosting query where you want to, like, you want to create a certain boost to say this particular part needs to be, like, if it is written by author being Joshua, but if you want anything like addition being 3, then give a negative boost. That means you're going to bring it into other side of the equation, right? I mean, there are specialized queries on that side as well. There are multiple absolutely multiple queries which will help you run through this one. Obviously my time seems to be running out. What I wanted to mention it to you is that before I end up this one, there is I mean, I haven't gone through the geospatial ones, but what I can show you is that, probably if I can bring it over to here, this one, let me come quickly, the GitHub. So if you go to my this Elasticsearch book code, you have something called Kibana scripts. You must have a compound queries, for example, or you have advanced queries. So if you go to advanced queries, you should be able to dump everything into your Elasticsearch. Certainly you go to copy that particular source code, you go to your console, you start playing with them straight away. You don't need to do everything. All these queries are pretty much tried and tested for 8.6 up to 8.6, so that should work straight away. So for example, if you're working with geo queries, this is the way you're going to do that actually. I mean, for example, in this case, I'm creating a mapping, and then obviously this is the once I have the query done, you can just simply use a geo bounding box query to get the data. For example, in this case, I am searching for a field called location, which is fitting up between top left and top bottom right, being this one. So if I show you very quickly, the way it's going to work out is that this one. So you have a geo bounding box query where you have a bounding box formed of 2 points, x1 and y1, which is your top left coordinates being the longitude and latitude, and the bottom left, which is basically bottom right, which is basically again another point, right? So this becomes a bounding box, and you are going to search anything in this bounding box using that particular query which has shown you here. So that's your geo bounding box. And same thing, it works for the geo distance as well, where you have a central focal point, and you are saying that actually 10 kilometers radius, find out all my relevant locations or whatever you are looking for, right? That's your geo distance query as well. And finally, you have a geo shape query where you have a big blue shape here. You're going to find out if plot A and plot B and plot D are they inside inside this shape. Your query will come back and say only plot A and plot B are within, and plot C is adjacent, and plot D is certainly not here, right? Now that's the way you're going to search for like a geo shapes. So at the end of the day, it's up to you. I mean, of course, there are other queries such as span queries and other things as well. You just go through this particular these scripts here, and that will certainly go over with you. Sorry, go to explain to you what those are at this point of time. I know I may have missed some of the questions. I got so many things at the moment. Um, but I'm really sorry about I can't. So what I would suggest is certainly get in touch with me on LinkedIn. Probably I should be able to help you out if I can have queries on that one. But really sorry about it. Yeah, I think that one of the questions seems to have been sorted out by contact. That's good. Yeah, I think I'll let you guys go. I have to give back my microphone. Is already 2 minutes over the time, so I will say thank you so much for being patient on the last 3 days. Elasticsearch is a really very beautifully orchestrated product. I would strongly suggest that if you're looking into search engine, and if it is the first time you're looking at it, try to pick it up, and you are really going to be in a fun ride. Of course, you don't need to, behind the hood there is a lot more complexity, but of course everything is hidden for us. There is a lot more documentation available for you. Certainly, you don't need to buy my book. Certainly, there is a lot more open source code which I exposed on the GitHub. Go over that, and there will be some more talks like this will be coming up in future as well, so that you will understand all this new stuff coming up along as well. So with that, I may have to hand over back to Adrian, who is patiently standing, sitting outside other side of my microphone. So back to you, Adrian. Thank you so much for your patience, and thanks everyone.
Yeah, thank you so much for presenting. Thank you everyone for watching. This was it, the 3-part series. Make sure to watch the first and the second part if you haven't done that yet. Wishing you all a very great rest of your day. Bye.